All right, this is the last section of chapter 6 or chapter 7. It is section 7.6, and the main focus for this section is to be able to take a 2x2 matrix and find its inverse. Let's see what we've got. Show that B is the inverse of A. Show that B is the inverse of A. Well, both of these are basically just two matrices, so A and B, doesn't really matter which one is which. One method that we have to show that if two matrices are inverses of each other is to do their product. So let's go ahead and multiply these together. And when I multiply, I have -1 plus 2, so that's the first element. Remember, you match up the corresponding parts, multiply and add. -1, 1 times -1, and 2 times 1 plus 2 is 1. And then we're going to do row 1 times column 2, so that's 2 plus -2, which is 0. And now we're going to jump down to row 2 times the first column, and that's -1 plus 1 is 0. And then times the second column, 2 plus -1 is 1. Okay, this does indicate that you have an inverse, and you'll know that you have an inverse because of the way your matrix is giving you the identity matrix. The identity matrix is when you have the diagonals are all 1 and everything else is 0. Here's another example of an identity matrix. A 3x3 identity matrix would be this. Diagonals are 1 and everything else is 0. We could do that for any size of a matrix. Okay, so this is how you can test if you're given two matrices if they're inverses of each other. Multiplication. All right, we've got several ways to actually find an inverse. What I can do is I can take this matrix A and I can multiply it by some matrix B. Well, what I'm going to do is I'm going to make that matrix B be an unknown matrix with x's. Let's say that this is x row 1 column 1, and this is an x row 1 column 2, and this is x row 2 column 1, and this is an x row 2 column 2. We're going to use a system of equations to do this. If I multiply these together, I'm going to get an equation of I've got 1 times x11, so x11 plus 4x21, or 21, and what that is going to equal is, since I want this to equal my identity matrix like this, then I know that the product, or that first row, first column, has to equal 1. Okay? And what I'm going to do is I'm going to do that for the other. I'm going to do that for the next row. So I've got row 1 times column 2 I got row 1 times column 2 here, and I would have x subscript 1, 2 plus 4x subscript 2, 2, and that should equal 0. And then my other two equations, I'm going to go ahead and multiply. I'm going with row 2 times each one of the columns, and so I'd have x subscript row 1 column 1, which is negative, minus 3x subscript column 2 row 1 equals, and that position here, when you multiply the bottom row by the first column, that should equal 0. And then the last equation would be multiplying by the second column. So negative x subscript 1, 2 minus 3x subscript 2, 2, and this would have to equal 1. All right, we got 4 equations, and obviously there are certain equations that need to go with each other. we need to go ahead and match up the equations that have the same variables. That would be this equation with the subscripts of 11 and 21 and this one. So let's solve the system between these two. Okay, if I solve the system between those two, I've got x11 plus 4x21 equals 1, and I've got negative x subscript 11 minus 3 subscript 21, and this is equal to 0. So I can add the equations together. I've got x subscript 21 would equal, and if I add those values together, it just equals 1. Okay, if x subscript 21 equals 1, back substitute, x subscript 11 plus 4 times 1 equals 1, so x subscript 11 would equal a negative 3. So we've got 2 parts to our matrix. Let's go ahead and solve the other system. My other system here, I would use these 2 equations. It looks like this. X subscript 12 plus 4x subscript 22, and this would equal 0, and negative x subscript 21 plus negative 3x subscript 22, and that has to equal 1. I can add these together, and I would get x subscript 22 is equal to 1, and then back substitute. X subscript 12, and I've got plus 4 times 1 equals 0, so x subscript 12 would equal negative 4. So here's what we're going to do. I'll write this matrix here right in the middle. Our matrix that we're trying to find, I've got row 1, column 1 is negative 3. Row 1, column 2 is negative 4. Row 2, column 1 is 1, and row 2, column 2 is 1. And so this is my matrix that is the inverse of the one that was given to me. And this is just one of the methods to find it, having to set up a system of equations. All right, now let's go ahead and look at another method, and this method would be to use the row echelon form. Okay, so we take our matrix and we're going to go ahead and put the matrix out here. But we also, what we want to do is we want to put next to it the identity matrix. If I can make the left side here to be equal the identity matrix by using my operations, then the right side will end up being my inverse. So what I can do is I can take row 1 and add it to row 2, and I'm going to replace row 2. I've got 0, row 1 and add, I've got 1, add, we get 1, add, we get 1. So I just added row 1 to row 2. Okay, the next thing that we're going to do, and again this is splitting up our matrix, the next thing that we would need to do is we need to multiply row 2 by negative 4 and add it to row 1. And what that's going to do is that's going to give us this position here to be 0. Let's see what we get. So 1, 0 plus 1 is 1. Negative 4 plus 4 is 0. Negative 4 plus 1 is negative 3. Negative 4 plus 0 is negative 4. And then my bottom row doesn't change. So I switched positions here. I made this the identity matrix, which means this is my inverse. So that equals the inverse of A. So there's our method 2 that we can use. All right, method 3 here. Method 3, we need to use what is called the determinant to find our inverse. The determinant is subtracting the cross products. So it is AD cross product this way, A times D minus B times C. Okay, this is the determinant of a matrix. It's called the determinant. This is how we find the inverse. So we do the determinant first. So the determinant of this would be -3 -3 minus -4. -3 minus a -4 is 1. So the determinant of this is 1. And you don't always get 1 for your determinant. So we would do 1 over the determinant of 1. Most of the time it's something else like 3 or 5 or -6. And then it looks like we switch some places around. So your D and your A completely swap places. So I'm going to swap the 1 and the -3. And then the B and the C change sign. So this is -4 and this would become 1. And your last step would be to multiply your scalar times the determinant. So your inverse would be equal to -3, -4, 1, and 1. All right, there's method 3. And finally, we've got method 4. Method 4 is using your calculator. In order to do the calculator, what you need to do is you need to go into the matrix program and you need to enter your 2x2 matrix. And you're going to enter all 4 elements, all rows and columns, and you can do that under matrix A. Once you have your matrix entered and you've been able to quit out of that, you just need to do matrix inverse equals, and it will give you the matrix -3, -4, 1, and 1. I think when you go to matrix, you're going to have to go to edit, and then it'll allow you to select matrix A, and then you can enter all the parts. But inverse is just to the -1 power. All right, here's what we're going to do. We're going to set up and solve the system of equations using an inverse, because if you can use inverses, here's what it looks like. If I've got matrix A times the matrix B equal to some matrix, okay? If I multiply by the inverse, what you're doing on both sides, what you're doing is you're basically allowing this to be your identity matrix. Okay, so you can use inverse operations to solve. Let's look at what would happen here. So if I have this as an equation, 2, 3, 1, and I can finish out my matrix with all of those rows and all of those columns. And then the right side here would be -1. And this would be 3, 3, 1, and 1, and 2, 4, 1, and -2. Okay? Well, what we're going to do is we're going to say, let's say this is matrix A, and matrix A, if we multiply matrix A by some matrix B, and matrix B is going to be the variables that we're trying to find, x, y, z, then it should equal -1, 1, and -2. Okay? So what I need to do is multiply both sides by the inverse of matrix A, the inverse of matrix A, and what you need to do is multiply, it does matter the order of multiplication, okay? So we need to do this. Find the inverse of matrix A using your calculator, and then you're going to multiply it by matrix B, and matrix B is this. You can do all of this in your calculator. You would do matrix A, enter all the elements, matrix B, enter all the elements, and then do inverse A times B. And that will also give you the x, y, and z values. So after entering matrix A, and b, and then calculating the inverse, you will get this matrix, 2, -1, -2. What that concludes is that's my solution of 2, -1, -2. That's the ordered triple to solve the system. All right, let's recap that. You're going to take the matrix right here, and you're going to enter the 2, 3, 1, 3, 3, 1, 2, 4, 1. That is a 3 by 3 matrix. Then you're going to enter the other column, -1, 1, -2, and that's a 3 by 1 matrix. You find the inverse of this one, and you multiply by the column matrix, and that'll give you your answer to the system of the solution. Okay, that is it for this section. There's your assignment. And you can see here that I want you to practice all methods, get a good idea of which methods you can use, and practice all of them.